So I mentioned the positive regulators, right? What are the positive regulators of the cell cycle and the negative regulators of the cell cycle? So in a brief, the positive regulators, those mainly drive the cell cycle. That means those mainly continue the process of the cell cycle. Those are mainly the positive cell cycle regulators. And the other, those mainly the negative regulators, those mainly affect the cell cycle negatively. That means that mainly stops or pause the cell cycle. So those genes or those proteins that mainly stops the cell cycle, or like those mainly halts the cell cycle, tries to repair the errors in the cell cycle. Those are mainly the negative regulators. So in positive regulation, these two are the main players in this positive regulation. These two are mainly the cyclin and CDK. Those are very important. So cyclin and CDK, those are the two proteins. Cyclin is cyclin and CDK is a kinase protein, which is cyclin dependent kinase. So from the name cyclin dependent kinase, you can guess that those proteins CDKs are dependent on the cyclin enzyme or cyclin protein. So when they are both together, they form a complex, CDK cyclin complex. And those complex, when they are together, they are activated, and those complex mainly then drive the cell cycle to the next phase. That mainly CDK cyclin complex, mainly it starts a chain reaction, right? It activates one protein, and that one protein will activate another one. It's like a chain reaction in the cell. So you can see that at at each of the phases, like G1, S, G2, M, there different cyclins are active at different phases. Like cyclin A is active at the end of the G1 phase, like in the S phase to M phase. You can see the cyclin A is activated, or the concentration actually increases. Like in the y-axis is the concentration of the cyclins. So this blue one is the cyclin A. So the cyclin A increases, the concentration of cyclin A increases in the S at the end of the G1 phase, or you can say at the start of the S phase up to the M phase. Also the cyclin B, it also starts to grow, its concentration rises at the start of the S phase and ends at the middle of the M phase. So depending on the cyclin concentration in the cell cycle is mainly positively regulated. So CDKs are always present, but the cyclins are not always present. So the level of cyclins mainly determines the phase. Like if there is S phase, the level of the cyclin A will be higher, and without cyclin A, the S phase will not continue. So here I have demonstrated that which phase which cyclins are active. You can see this green one, like in the M phase. The green one is the cyclin B. So cyclin B will bind to CDK1. So CDK is also divided like CDK1, CDK2, CDK4, 6. So again, the complex CDK cyclin complex, those are mainly active. So without CDK or without cyclin, the cell cannot go in the next phase. So the positive regulator, the cyclin and the CDK. Here you can see that I mentioned that here's the CDK and the cyclin. So when they are together, they form a complex. The complex is CDK cyclin complex, and when they are together, they are active, so that they can activate other proteins, which are like this substrate is another protein. So you can see that the kinase, from the name, the kinase means they transfer phosphate groups to another substrate, another protein. So in this figure you see that the substrate is phosphorylated. So when it is phosphorylated, this substrate is activated. So that means this protein is activated, then this protein will further catalyze another reaction. This protein will catalyze another protein, and when this cyclin is detached, then they again become inactivated, this cyclin and CDK. But when they are together, they mainly uh, phosphorylates or activate other substrates. So in this figure is like the demonstration of the other figure, the previous one, but it is in details. Like in the G1 phase there's CDK, and there's a specific cyclin. Cyclin is specific for a specific phase. Like in the G1 phase there's like G1S phase specific cyclin, which is from the previous one. What is the specific cyclin for this phase, G1S phase? The cyclin is, I guess, cyclin A or E, I guess. So um, sorry, so cyclin D. So this G1 phase, this G1S phase, specific cyclin is cyclin D and cyclin E. Actually, those are the two specific cyclin for this specific phase. So in the G1 phase, but in the next phase, their cyclin is like when they're merged complex, then they mainly drive the cell to the next phase, which means when they're together, they drive the S phase. So S phase then starts. Then further, another specific cyclin comes, because earlier cyclins then degrades. The new cyclin comes, the specific cyclin. Those mainly drive this replication process further, and when their function is done, then they mainly degrade again. A new cyclin comes at this G2 phase. So here is the function of the cyclin and CDKs are shown. So depending on the each phase, the different cyclins comes and drive the phases. Like each phases of the cell cycle then proceeds.